In this video, we're going to go through some guided practice relating to conservation of energy. Okay, so there's two sides to this practice. The first side we're going to do together. The second side you're going to work through on your own. But the second side is just like the first side. It's just a different problem. So we've got a roller coaster. Okay, so roller coaster starting out really high at the top of this hill. And I want to know how fast the roller coaster is, what the velocity is going to be at this point right here. Okay, so we can actually figure this out using conservation of energy. Now we're going to assume that there isn't friction in this case. Friction is going to change things a little bit, but in this perfect world that we live in, we're going to assume that there's no friction. So there's two things that we need to do. Okay, step number one is to find the total mechanical energy at point A. Okay, so let's start by doing that. At point A, we know that the mass of our roller coaster cart is 3,000 kilograms. We know the height of the roller coaster cart is 40 meters. And we know the acceleration due to gravity is always going to be 9.8 meters per second squared. Okay, we're trying to find the potential energy. So we're just going to use the regular PE equals mgh formula. Okay, so we plug in all of our numbers. So 3,000 kilograms, G, which is 9.8 meters per second squared, and the height, which is 40 meters. Okay, so let's go type this in on our calculator. Okay, so we have 3,000 times 9.8 times 40. All right, so we have a really big number here, and that's fine because this is a roller coaster and they're really heavy. Okay, so what do we have? 1,176,000 joules. Okay, so there is our potential energy. Okay, now, second part of finding the mechanical energy is the kinetic energy. Okay, so at point A, at the very top here, all of our energy is going to be potential. Okay, even here it says assume the velocity at point A is 0. So if your velocity is 0, you can't have any kinetic energy. So I'm just going to write in here KE equals 0 joules. All right, next it asks us to find the total mechanical energy. Okay, the total mechanical energy is the potential energy plus the kinetic energy. Okay, so this should be pretty easy. Total mechanical energy is equal to KE plus PE. Since we know that our kinetic energy is 0, I'm going to go ahead and do the math here. So kinetic energy 0. Potential energy is this really big number, 1,176,000. Okay, if we add those numbers together, we're just going to get the same 1,176,000 joules. Okay, so at the very top, our total mechanical energy is going to be equal to our potential energy. In this case, because we're not moving. Okay. Says down here, the total mechanical energy at point A is blank to the total mechanical energy at point B. Okay, so equal. Remember, our total mechanical energy never changes. Okay, so the total mechanical energy at point A is going to be the same at point B. Okay, we're going to have a different amount of potential and kinetic energy, but the total mechanical energy is going to be the same. All right, next thing that we're going to do is we're going to find the velocity at point B. Okay, to do that, we're going to need to figure out a few things. The first being the potential energy at point B. Okay, so at point B, we still have the same 3,000 kilogram roller coaster cart. G is going to be the same, 9.8 meters per second squared, but our height is going to be different. Our height's only going to be 25 meters here. Okay, so our height is going to be 25 meters. G is going to be the same, 9.8 meters per second squared, and our mass is going to be the same, 3,000 kilograms. Okay, so again, we're just going to plug straight into our potential energy formula, which is PE is mgh. The mass is 3,000 kilograms. G is going to be 9.8 meters per second squared. And our height is going to be 25 meters this time. Okay. So let's go ahead and plug this into our calculator. So instead of it being 40, I'm going to change this to 25. Okay. So our potential energy is going to be 735,000 joules. Okay. Now, here's where it gets a little tricky. Question 5 says, what is the kinetic energy at point B? So a couple things that are going to be really important here. The total mechanical energy is going to be the same at point A, point B, and everywhere in between. Okay, so let's write out our formula to find total mechanical energy. Okay, so if the total mechanical energy is the same at point A and point B, I can plug in the total mechanical energy that we had at point A, which is 1,176,000 joules. That's going to be equal to the potential energy at point B. Okay, we just found that right here. Okay, so 735,000 joules minus the kinetic energy. Okay, so to get this by itself, or it should be plus the kinetic energy. To get this by itself, I'm going to subtract 735,000 from 1,176,000. Okay, so let's do this on our calculator. I'm going to get kinetic energy by itself, so 1,176,000 minus 735,000 gives me 441,000 joules. Okay, so that's going to be our kinetic energy at point B. Now, it says use the kinetic energy from question 5 to calculate the velocity at point B. Okay, so to find the velocity, it's going to be the square root of 2 times the kinetic energy over the mass. Okay, that's our formula. So we're finding the velocity, 2 times the kinetic energy at point B that we just figured out, so 441,000 over the mass. The mass of our cart is still 3,000 kilograms, and these are joules. Okay, so this is where it gets a little tricky putting this in our calculator. Okay, I have a graphing calculator here. It's a little bit easier. I'm going to do the steps that we would normally do on the blue calculators that we have in our classroom. So I'm going to do the top first. So 2 times 441,000. So that's the numerator inside of our square root. So I'm going to hit enter. Now I'm going to divide that by the denominator, which is 3,000. Enter. Okay. And then I want to take the square root of that number. Okay, so I'm going to go second square root and then second answer. Enter. Okay, so the velocity at our point here, I'm going to just take it out to one decimal place, so 17.1 meters per second. That's really fast. All right, so what I need you to do, okay, so we went through the whole process here, so how to figure out the total mechanical energy, how to figure out the kinetic energy, and then how to use that kinetic energy to find the velocity. Okay, so what I need you to do is to work through a similar problem. Okay, so you're going to find the total mechanical energy here at the start. Okay, so all the information should be here in this picture. And then what I want you to do is find the kinetic energy at point A. So follow the same steps that we did, and then use that to find the velocity at point A. Okay, so if you're not sure what to do, go ahead and look back at what we did up here, and it's the exact same steps. Okay, so I'm expecting you to have this all filled in on the first page from watching the screencast, and then I want you to work through this on your own, and then go ahead and turn it in. Okay, good luck and have fun.